This is the Algebra 2 Unit 5 review. Starting with question number 1. And it says the square root of 120. Now you can do a factor tree for this thing if you want. I told us to go ahead and divide by perfect squares, so there's a 4 in there for sure. So there's a 4, and then if I divide that by 4, I'm looking at 30. Alright? 30 doesn't have any perfect squares in it, so this equals 2 root 30. Number 2 says 5 root 48. Alright. And so you're looking for perfect squares. And so if you look at 48, try to divide it by perfect squares. So we have like 16, 25, things like that. And 16 goes in there. You're going to have to 5 times the square root of 16 times the square root of 3. 16 is the biggest perfect square. Which is 5 times 4 times root 3. So it'll be 20 root 3. Number 3 says 3 square root of 20 times 5 square root of 15. And either you can put these together first or you can simplify them first. It's kind of up to you. I'm going to simplify them first. So I know that 20 is the same as 4 times 5 using the product property for radicals. And I can't do anything with the square root of 15. So this basically equals 3 times 2 times root 5 plus 5 times root 5. And then we're looking, oh, sorry, this is times. 6 times root 5 times root 15. Okay. And then looking at this, I'm going to say 30 times 5 times root 15. Okay. Now I can multiply this out and realize it's going to be 75, or I can just go ahead and realize that 15. Okay, there's my 5 is the same as 3 times 5, and there's my pair of 5s. So I'm looking at 30 times 5 times root 3, and that's going to be 150 root 3. Number 4 says 2 root 5 squared. Okay, you can use a shortcut, or you can just realize that this equals this. So 2 times 2 is 4. 2 identical radicals times themselves is just a number underneath. And we're looking at 20. Okay. Looking at number 5 here. 5 is not the same type of question. Okay, or it is the same type, it just acts differently though. Okay, this is equal to 2 plus root 5 times 2 plus root 5. Okay, and this needs to be FOILed. So we're looking at 4 plus 2 root 5 plus 2 root 5 plus root 5 squared. Okay, so this equals 4 plus 4 root 5. This turns into 5. Combining like terms, I'm looking at 9 plus 4 root 5. Number 6. That says the square root of 4 over 10. And I'm going to go ahead and use the quotient rule for radicals and split this up. And this equals 2 over root 10. Okay. Now that's simplified, but now I have to actually rationalize it. So I'm going to multiply by root 10 over root 10. Okay. And that gives me 2 over root 10. Remember, 2 identical radicals times themselves is 10. But now this can also be reduced. Leaves me with the 1, leaves me with the 5. So I'm looking at root 10 all over 5. Number 7 says 4 over root 10. Okay. Multiplying by root 10 over root 10 to rationalize, I'm looking at 4 root 10 all over 10, and this also reduces all the same way. So this is going to equal 2 root 10 all over 5. Number 8 is 3 root 8. So I can either simplify the radical first or rationalize it. I'm going to go ahead and simplify it first. So this equals 3 all over root 4 times root 2, which equals 3 over 2 root 2. Okay. Now I'm going to rationalize it. All you need to multiply by is the radical. So I'll multiply by root 2 over root 2. Okay, and I'm going to kind of come down here. And I'm looking at 3 over root 2 equals 2 times root 2 times root 2. Okay. And I'm looking at 3 root 2 all over 2. Now this root 2 times that root 2 is just 2. And so my final answer is 4 root 2, 3 root 2 all over 4. Number 9. Let's squeeze this on this piece of paper. Number 9 is 20 over root 11. You can't simplify root 11, so I'm just going to go ahead and rationalize it. And this equals 20 root 11. Two identical radicals times the self is just a number underneath. And there you go. Nothing to reduce there. Number 10, you can't reduce number 10, but you can rationalize it, and you have to use a conjugate for this. Okay. So look at number 10. We're looking at 4 all over 2 plus root 7. Okay. And I'm going to multiply by the conjugate. Okay. And the conjugate is you keep the front number the same, and you just change the sign in the middle. Okay. And think of these as binomials. Okay. They kind of are because you can't really add the radicals. So up top, I'm going to use the distributive property, and I'm looking at 8 minus 4 root 7, and down below I have to FOIL. So I'm looking at this one times this one is 4. The outside times outside is 2 negative root 2 root 7 plus positive 2 root 7 minus root 7 squared. Okay. And then I'm looking at 8 minus 4 root 7, okay, all over 4. Those should cross out if I did use a conjugate. Minus 7. Right, because remember a square root and a square are inverses, and then we're looking at 8 minus 4 over 4 root 7 3 all over negative 3. Okay. 11 is 6 minus 2 root 3 all over 1 plus root 3. And once again, I got to multiply by the conjugate of the bottom, right? But I got to do it to the top and the bottom. Okay. And then up top, I'm going to FOIL. And so 6 times 1 is 6. 6 times root 3 is negative 6 root 3. Negative 2 root 3 times 1 is minus 2 root 3. And negative is a positive 2. This time I'm going to say root 3 times root 3 is just 3, and it's times 3. Down below, I'm looking at 1 minus root 3 plus root 3 minus root 3 squared. Okay. And then we're going to have up here, we're going to have 6 minus 8 root 3, simplify that over there, plus 6 all over 1 minus 3. Those cross out. This is going to be just 3 here. So we're looking at basically 12, those are both positive 6, minus 8 root 3 all over negative 2. And from here I'm actually not done. I can actually reduce. And what I'm talking about is I can factor out a negative 2, or it doesn't really matter. You could factor out just a 2, but if I factor out a negative 2, we're losing with negative 6 plus 4 root 3 all over negative 2. Now I can reduce those because they're being multiplied. My final answer is negative 6 plus 4 root 3.